next part is of data normalization. Right, data normalization is the concept कि कैसे data evolve हुआ, कैसे हमने data को store करना start किया था और कैसे कैसे हम उस पे लेके आए कि इस format में आपको data होना ही चाहिए, then we'll get a good results. Right? So these are the various contents that we'll be covering in unit 6. Right, functional dependency. Functional dependency are the constraints on well-formed relations and represent a formalism on infrastructure of a relation. See, the first definition is a functional dependency FD on a relational schema R is a constraint X to Y where X and Y are subsets of the attributes of R and Y functionality depend on X or X uniquely determines Y. That means with the help of X we can uniquely identify the value of Y. X is a determinant, Y is an attribute. X determines Y. Y is functionally dependent on X. X to Y is a trivial if Y is a subset of X. Definition 2. An functional dependency X to Y is satisfied in an instance R of R if for every pair of tuples T and S, T and S agree on all the attributes in X, then they must agree on all the attributes in Y. Example, functional dependency, let R be a new student, ठीक है, उसके ये attributes हैं. Functional dependency R include स्टूडेंट आईडी लास्ट नेम. तो स्टूडेंट आईडी के थ्रू हम लास्ट नेम डिराइव कर सकते हैं. स्टूडेंट आईडी के थ्रू हम लास्ट नेम, मेजर, क्रेडिट, स्टेटस एंड एसएसएन वी कैन डिराइव आउट. विद द हेल्प ऑफ एसएसएन वी कैन डिराइव आउट स्टूडेंट आईडी, लास्ट नेम, मेजर, credit, status. Right, so this is functional dependency. Types of functional dependencies. There are two types of functional dependency: trivial functional dependency and non-trivial functional dependency. Trivial functional dependency, the FD X to Y is trivial if set Y is the subset of set X. If A and B are the attributes of R, A, B, A, B, B, A, B, A, B are all trivial functional dependency and will contribute to evaluation of the normalization. Non-trivial is the functional dependency X to Y is non-trivial is set Y is not a subset. वो subset नहीं है X का. A tends to B, like student name, student ID, student name. So it is not the subset of A. There are functional dependency axioms. Functional dependency are recognized by analysis of real world. No automation or algorithm. Finding or recognizing them are the database designer's task. These are the various axioms: reflexivity, augmentation, transitivity, union, decomposition or projectivity, pseudo-transitivity, and no. Right? These are the few axioms. If A is a set of attributes, B is a subset of A, then A tends to B. Right? This is the example. If A tends to B, holds, and C is a set of attributes, then CA tends to CV. Right? The examples are very clear. SSN is name, then SSN phone can lead to name and phone. If A tends to B, holds, and B tends to C, holds, then A tends to C. Right? That is transit. अगर A से tends होता B, B से C, तो A is automatically tends to C. Right? If A tends to B and A tends to C, holds, then A tends to BC also holds. SSN name and SSN zip. That then SSN should tends to name comma zip. Decomposition, if A tends to BC holds, then A tends to B and A tends to C. See, the axioms are very clear and very easy to understand. Just understand the word transitivity. Pseudo transitivity क्या है? A tends to B, CB tends to D. Hold that AC, B तो क्या है ही दोनों में, AC tends to D holds, right? These are the few examples. तो जब हम इसको practice में लाएंगे तो it will be very clear. कोई दिक्कत नहीं आएगी, right? Closure of a set of functional dependency. Given a relation schema R, a functional dependency F on R is logically implied by a set of functional dependencies F on R if every relation instance R that satisfied F also satisfies small f, right? The closure of F denoted by functional dependency F plus is set of all the functional dependencies logically implied by F. The closure of F can be found by using a collection of rules called Armstrong axioms, right? So these are all the Armstrong's axioms जो हमने discuss कर ली हैं, right? These are all the Armstrong axioms. This is an algorithm to compute functional dependency. All the function to compute the closure of a set of functional dependency F. Functional dependency is equal to F. Repeat for each functional dependency F in F plus. That means set. Apply reflexivity and augmentation rules on F. Add the resulting functional dependencies on F plus, right? For each pair of functional dependency F1, F2 in F plus, if F1 and F2 can be combined using transitivity, then add the resulting functional dependency until F plus does not change any further large, right? Suppose we are given a relation schema R A B C G H I, right? And the set of functions dependency A tends to B, A tends to C, CG tends to H, CG tends to I, B tends to H. We list several members of F plus here. A tends to H, right? We can do. Since A tends to B and B tends to H, तो transitivity rule apply हो रहा है. CG tends to HI. Since CG tends to H and CG tends to I, the union rule implies CG tends to HI, right? Next is AG tends to I. Since A tends to C and CG tends to I, the pseudo transitivity rule implies that AG tends to I holds, right? So ये rules हम जब apply करते हैं तो हम उसको use कर सकते हैं और हमें समझ आता है, right? Next is the part of normalization. Normalization, देखो, while designing a database out of the entity relationship model, the main problem existing in the raw database is of redundancy. Redundancy is storing the data item in more than one place. जब data redundant होता है तो problems आती हैं. A redundancy creates several problems like the following. Extra storage space सबसे मेन चीज है. The same data in many places takes large amount of disk space. Entering same data more than once during data insertion, right? डेटा और दो तीन बार इंसर्ट करना पड़ता है. डिलीटिंग डेटा फ्रॉम मोर देन वन प्लेस ड्यूरिंग डिलीशन. अब डिलीशन करते टाइम भी बहुत सारी प्लेसेस से डिलीट करना पड़ेगा. मॉडिफाइंग डेटा इन मोर देन वन प्लेस. Anomalies may occur in the database if insertion, deletion, modification, etc. are not done properly. It creates inconsistency and unreliability of the database. To solve this problem, the raw database needs to be normalized. This is a step-by-step process of removing different kinds of redundancy and anomaly at each step. At each step, a specific rule is applied to remove specific kind of impurity in order to give the database a slim and clean look. सबसे पहले unnormalized क्या होता है? If a data contains non-atomic values at each row, it is said to be unnormalized form. An atomic value is something that cannot be further decomposed. A non-atomic value, as the name suggests, can be further decomposed and simplified. Consider the following table, right? This is the table. So this is the unnormalized form. In the same table above, there are multiple occurrences of rows under each key employee ID, although considered to be a primary key. Employee ID cannot give us a unique identification facility for a single row. Further, for each primary key points to a variable length. A relation is said to be in first normal form if it contains no atomic values and each row can provide a unique combination of values. The above table is in unnormalized form, can be processed to create a normalized form. ये first normal form है. Right, as you now see, each row contains unique combination of values. Unlike in unnormalized form, this relation contains only atomic values, that is, the row cannot be further decomposed, so the relation is in now first normal form. Second normal form. A relation is said to be in second normal form if it is already in first normal form and each and every attribute fully depends on the primary key of the relation. Speaking inversely, if a table has some attributes which is not dependent on the primary key of the table, जो attributes आपके present हैं और primary key पे depend, then it is in not in second normal form. Let us explain. Employee ID is the primary key of above relation, right? Employee name, month, sales and bank name all depend on employee ID, but the attribute bank name depends on the bank ID, right, which is not a primary key of the table. So the table is in first normal form and not in second normal form if this position can be removed and another related relation, it would come in second normal form. Now this is the way. अब हमने एक नया relation बना दिया जिसमें हमने bank ID और bank name रख दिया, right? Now it is in second normal form. After removing the portion into another relation which store lesser amount of data in two relations without any loss of information. This is also a significant reduction in redundancy. The third normal form, a relation is said to be in third normal form if it is already in second normal form and there exists no transitive dependency. हमने transitive dependency भी पढ़ा था. A tends to B and B tends to C. That means A tends to C, right? If a table contains speaking inversely, if a table contains transitive dependency, then it is not in third normal form and the table must be split to bring it into third normal form, right? What is a transitive dependency? Basically, with a relation, if we say B depends on A and C depends on B, then we may derive C depends on A. Such derived dependency hold well in most of the situations. For example, if we have role, marks depends on role and grades depend on marks, then we may safely derive grade depends on role. This third dependency was not originally specified and have derived it, right? So agar there is no transitive dependency exists in the table or a relation, then it is in third normal form. Thank you. I hope you understand, right? There are many normal forms, but these are the part of your course, right? Thank you and have a nice day.